I'm Kelsey. I'm the Director of Product Management for our federal business line and global government use cases. I'm going to cover quite a few things today. I'm going to start with the differentiating capabilities of X10 as a whole, and then go into the differentiating capabilities of X10D, which is our all gray offline dual use variant that we've added some additional resiliency, security, and modularity components to make it optimal for the federal and global government use cases. So starting with the X10 capabilities, Skydio provides AI-powered small UAS solutions that allow customers to see and sense the world around them. So this is incredibly important because it allows pilots to accomplish complex tasks while also lowering the cognitive load and allowing you to get back to the mission sets that you actually care about and the things that you want to be doing on a daily basis. So one of the ways that we do this is by our groundbreaking vision-based navigation system. This isn't an add-on, something that we've seen and tried to iterate on with GPS-denied environments. This is something that's inherent to Skydio products that we have been honing and adjusting and really becoming experts on over the last 10 years. We have honed this through our dual-use products and through government use cases, but from the landscape that I've seen, this is something that a lot of people have added on with different attachments, tried to get vision-based solutions, but we're probably 5 to 7 years ahead in this space because of the way that we've built the hardware and that we've integrated our vision-based solutions. This is really impactful, like I mentioned, for the GPS denied space because we inherently have a vision-based solution that we're able to employ when GPS denial happens or you need another visual positioning system to use as a contingency. So the way that we do this is we have 6 embedded navigation cameras inside the aircraft that provides 360-degree navigation view bubble around the outside of the aircraft that provides you another worldview. So if you think about the GPS frame that you're operating in for navigation systems, we also have a navigation frame that we're able to, or a visual navigation frame that we're able to navigate off of. We also have a new capability that's launched this year called Night Sense, which is part of what you're seeing here, which allows you to be able to fly and use these vision-based capabilities at night. So that's one of the attachment capabilities that I'll talk about a little bit later. But we have, like I said, 6 embedded custom navigation cameras that can be either visual or infrared. That provides you 360-degree coverage around the aircraft, industry-leading obstacle avoidance, and visual-based positions in GPS-denied environments. And this isn't only for battlefield applications or specifically for military applications. It has many other dual-use applications as well, including flying in places like subway tunnels, under bridges, really any area where you think that you could potentially have intermittent GPS spoofing, any type of GPS denial. This is able to cover that for you. And I think we're going to show a cool video of, yep. So this is some indoor capture that we've done from GPS denial using our vision-based position systems and kind of the sense of the world around you as you're using these vision-based position systems. Another thing that we've done with our X10 platform is we now have 10x compute, which I know is just the inverse of the other, but we have 10x compute of what we had on X2. So this is really impactful because it allows you to have additional pixels on target for precision and data capture, and also allows you to have exceptional edge computing on the platform, which unlocks an entire myriad of things that you can do with the platform that you wouldn't be able to do with lesser compute. So with this, we are empowering a bunch of different algorithm sets. We do 2D and 3D map capture, onboard modeling, subject tracking. The possibilities are endless for what we're actually able to do here. We've had the Scout capability for a while. This also employs the Scout capability. And it also is very impactful for what we're seeing in contested environments and for the hardware as a whole, because it allows us to continue to grow and adapt with the continually evolving mission needs. So we're using a portion of that compute now, but we have the capability to grow over time to encompass whatever mission sets that we're going to be able to accomplish. And on the 2D and 3D map capture and onboard modeling side, we have one of our experts on the line too. And Jonathan, do you have anything to add on any of those?
Yeah, so Skydio, as everyone's mentioned, we built around computer vision and autonomy. And one of the core features we've had, for a while now on our previous platforms was 3D scan, which is basically the drone having an autonomous flight path to capture data to make robust 3D and 2D models, 2D maps and 3D models. With X10, we took this, beyond the sensors, which Kelsey will get into, and things like that. We took this to another level with the additional compute. Is essentially we have a workflow now where you can fly a map capture, which is our 2D a 2D flight plan, or our 3D scan. Fly that the drone autonomously, so you'll see captures the data, which is not unique to us, but we do it pretty simplistically. This is a 2D map capture that you're seeing here. And then once we capture that data, which is all, you can set a lot of parameters up front to get the GSD you want, to get the angles you want, etc. What happens when you land is you can actually process the scan, and this is a little bit sped up, but it's a matter of minutes, not hours. But essentially, you process this scan and onboard the drone. Give it a second to show here. On board the drone, you actually get both a 3D model, and when you're doing a 2D map capture, you get a GeoTIFF, which is a georectified orthomosaic, which can be utilized for mapping purposes and base maps and things like that. So what's really neat about this, and being an avid drone user for the last 15 years, is that you actually can see the data that you've captured, make sure you've got the correct information from an ISR perspective. It gives you pretty much edge, offline capability to show a post mission report or a pre-mission plan, so you get this data in the field without connecting to an online source, not needing a computer program like a photogrammetry program to create these models and geotiffs. They're lower resolution than you'd get on that because they're lightweight, but they're you can see a lot of detail still, and you still get the raw files that you can post process as well. But it's a cool new feature that we've launched with X10. I've used it a lot. It's been impressive on demos and then just in general use. And I'm excited to see how our customers use this, moving forward.
Great. Yeah, thank you. And I think as you saw in the video, this also unlocks several other readiness use cases that we see across the global government space, including asset health management, asset inspection, base security. There are multiple different things that you're able to do with this all in one platform, not having to expand with different variations of the platform, different attachments. This is all built into the platform inherently. Awesome. Okay, so as the director of product management for our federal vertical, I'm in charge of all of our feature sets and use cases and the user experience and design, and we take that experience very seriously. So the way that we do this is we're talking directly to the end user to be able to use their feedback and directly iterate that into the product. We do this as quickly as possible and use a build and iterate approach to be able to accomplish this. And in doing this, we're able to iterate extremely quickly, get that feedback into the product line, and use our expertise within our cross-functional teams to be able to build the right solutions. So the way that I do this personally is making sure that we understand the customer use cases, taking those and generating the requirements that are needed, and then taking those to the cross-functional engineering teams and allowing them to really think through the problem sets, make sure they understand the problem and come up with the best solution, sometimes a very novel solution that we hadn't thought of before, and iterate and build quickly. And we have the test team completely integrated into this, and Nicole will talk about that a little bit later. But it's really important to build quickly and make sure that we're getting the feedback from the customers, and we have groups of subject matter experts that we're continuously leveraging. We're talking to our customers all the time. We try to go out and really meet the customers where they are, being on site with them, traveling to different events, really seeing what they're experiencing with the product and making changes as quickly as possible, but also really inherently embodying the principles of reliability and making sure that we're not just building development products, we're building products that can scale over time, have very high reliability, work out of the box the same way every single time, and are able to get into customers' hands and be the easiest user experience possible so that you're not using up your cognitive load to be able to operate those products. So based on all the feedback that we've gotten, we have customers all over the globe employing these products and have gotten a lot of great feedback. And we've taken that feedback and used that to create X10D, which is the product that we're going to talk about now, which, as I mentioned, is our offline dual use variant. It's an all gray variant that we've implemented a bunch of other resiliency, modularity, and security features into. So because we are operating all over the world in different environments, we're seeing the feedback coming out of our near peer conflicts that are happening in Europe. We need to take a very layered approach to make sure that we're able to accomplish the needs that we have for all of the different dynamic environments that we're encountering. So the way that I personally think about this is kind of divided into two different groups when you're talking about resiliency. And that's the first concept that I'm going to talk about for X10D. So on the resiliency front, we know that these are happening simultaneously. We know that they're encountering radio frequency denial and GPS denial simultaneously, but you can think about them kind of in two different lines of effort. So on the RF denial front, really starting from the basics, you need a wide range of frequencies to be able to operate within. So we have a multiband radio. You're able to select a frequency that you think will give you the best operating environment, as opposed to just picking like 1.8 or 2.4, picking a discrete frequency. We have a wide range of frequencies that you're able to choose from. If the frequency that you've chosen isn't optimal and you do encounter jamming, we've implemented another capability, essentially allowing you to have agile frequency switching, where if you encounter jamming while you're in the middle of your flight, you're able to transition to another frequency and hopefully evade that jamming. So we have a proprietary algorithm that's based on a bunch of different thresholds for a GPS and jamming environment that allows you to constantly evade any type of enemy signal or degraded environment. Even in a CONUS environment, if you're experiencing something that is degrading your RF signal, it allows you to immediately jump to a new signal and potentially have better capability. Another really cool thing that we've done for radio frequencies is we now have an external radio capability where you're able to connect to your radio, position that new radio hundreds of feet away from you, and fly from an area with better cover and concealment. Really cool feature that we're getting a lot of great feedback on. Essentially allowing you to fly from within a bunker or a vehicle, somewhere where you have better cover and concealment, or even if you just want to relax and sit down somewhere that's outside and not next to the LZ, you're able to do that now with this new capability. And something that we're seeing really impactful in contested environments and in Ukraine is being targeted for an RF signal. It allows you to be distanced from that RF signal and be in an area that is potentially more safe. So that's the RF front. On the GPS front, as I mentioned, we already have a lot of inherent capability built up for GPS denial with our vision-based solutions. So if you do encounter GPS denial, you're able to use your vision-based solutions that we have inherently built in the platform as the first level of resilience, which generally is impactful in itself. But if you do need additional contingency measures, we also have the industry standard attitude mode that you're able to fall back to. This capability we had on X2, but we've made a lot of really great improvements for our new X10 capabilities. It allows it to be a more stable attitude mode, able to continue out, accomplish your mission, and come back and potentially recover the aircraft. So with our vision-based solutions and attitude mode, that already provides you a pretty good solution to be able to potentially accomplish your mission in these GPS degraded environments. And also with our new vision-based capabilities and the improvements that we've made to our navigation camera lenses, we're now able to fly at even higher altitudes than we were previously for our vision-based solutions, which has been really impactful. Another thing that we've seen from our discussions with end users and that we've just seen on the battlefield in general is that customization is really important. Depending on the mission set and depending on what the mission entails, many different users want other configuration settings for what the drone will actually do when it encounters some of these degraded environments. For example, if you encounter a degraded environment, we now have the capability to return back towards your home location as opposed to just landing and doing an emergency landing in a contested environment zone and potentially not recovering that aircraft. We now have the ability to come back. And there are many different settings that you're able to go into and determine how long you hover, where you return to, just multiple different options to be able to set contingencies and make that work in the best way possible for your mission specifically. So outside of the specific EW resiliency measures that we've put into the aircraft, we also have multiple security measures in general that help deter any type of hostile action that could potentially happen to the aircraft. So all of our components are NDA compliant. They're sourced from the same companies and vendors that we personally hold ourselves the same standard to. We utilize AES 256 encryption for our wireless link. We also have digital and physical security, including, but not limited to, encryption on our hard drives with password protection. We do key burn-in utilizing YubiKey and multiple other security options. So on top of our digital resiliency measures that we have for just EW specifically, the aircraft and the links and controller are also very, very hardened to be able to deter any type of enemy action. Additionally, so we talked about resiliency, we talked about security a little bit, and now we're on to the modularity of the platform. So as I mentioned, we have that 10x compute available that allows you to adapt to continuing solutions on the battlefield. We do have a software-defined platform, so we're able to continue to advance as needed. But lots of different levels of modularity here with our platform, starting with the gimbal solutions. So this is something that we've taken a lot of pride in increasing our sensor fidelity, making sure that we're actually able to get the imagery in real time that you need to make decisions on the battlefield. We have two different gimbals that we're using to be able to do this. One of them is references VT300Z, which is the gimbals you can kind of think about in two different flavors. They're primarily based on use cases. So the Z variant provides more situational awareness. It can be used for inspections in a very capable way. But the other variant, the L variant, is for inspection specifically. Both of these have our FLIR Boson Plus included in it, which provides groundbreaking radiometric thermal capability. Jonathan, do you have anything to add on the gimbal front?
Yeah, sure. So, as Kelsey mentioned, we have two gimbal packages. I think what's interesting with the X10 over some of our previous iterations here is these are upgradable sensor packages. So as we release new sensor packages on the front part of the aircraft, we can replace these. And that's lets you have future modularity and future upgradability of this platform. So it truly is a platform. I think specifically on our two sensors that we have to date, the VT300Z, as Kelsey mentioned, is really the de facto ISR and tactical package that we're selling across the world right now. Diving into the sensors a little bit, the Boson Plus, we were the first to integrate this. It is a 640 radiometric sensor with about 30 to 40% more sensitivity than the typical Boson. And we take that a level further with our custom tunes on this. So we're really focused, like as you can see here, on the recon element when it comes to ISR. So we have a specific tune for recon, which really lets, in reconnaissance and search and rescue and things like that, you can see a person or a vehicle, and it really pops when you're in convoluted locations like forests and things like that. So I've used this quite a bit. We've done some demos here. Our customers have been using this, and it's really it's a game changer in terms of sensor performance and this size of aircraft. When it goes to the electro-optical sensors, the visual sensors, we have two, as Kelsey mentioned, on this VT300Z. So we have a 64 megapixel narrow, so it's about 50 degrees field of view, and then we have a 48 megapixel telephoto, which is about 13 degrees field of view. So it's similar to some of our phones work. So we smoothly, when we're zooming, you smoothly transition over to the other sensor on the electro-optical side. Our UIs, in my opinion, improved too from previous iterations, where you can actually cycle through these quickly. You can reset the sensor package. You can go to a max 128 zoom really fast, or back to zero. Actually 0.5 is what we call it, which actually stitches the nav cams together. So you have a lot more optionality there. And standoff distances are much more improved. So this aircraft's pretty quiet. I personally think it's quieter, depending on what frequencies your ears are tuned to, than the X2. But our standoff capability is much increased. So this is a very, for ISR purposes, this aircraft is very stealthy. And jumping over to the VT300L, the difference there is the L versus Z. That is the de facto inspection package. Though both of these sensors can be used in many use cases. All our functionality works on both in terms of 3D scan and things like that. But the L brings a little bit different. It gives you a wide sensor, so 1 inch, so more light, more per pixel essentially. So it's a better detail at low light and then close up to objects. It's wide in the sense it's 93 degrees field of view. So for mapping and modeling and things like that, you can essentially take less pictures to cover the same object. And then you have the same narrow sensor as well, which was the 50 field of view. You also have the FLIR here, so for inspections, for hotspots, solar inspections, a lot of other commercial use cases and other use cases. It's great for that. And then it comes with a flashlight as well. So I personally use this in tunnels, as Kelsey was mentioning earlier, where it's pitch black. We're flying pitch black with Night Sense, which is an attachment we'll talk to you in a little bit. But you can turn this flashlight on and see around you too. So it's pretty useful for inspections when you're close up. Obviously it's all tuned with our optical avoidance, so you're not concerned about crashing or hitting anything. You can get really close to objects, inspect them with our stop at structure mode. You can basically it's sticky on the object you're looking at. So it's a system of systems here. We built these sensor packages in lieu with our optical avoidance, with our autonomy, and it just really works really well.
Thanks, Jonathan.
Yep.
So we talked a little bit about the upgradable sensor packages, which we just discussed. We also have a suite of first-party payloads that we've launched with X10 that ties into the 4 available payload ports that we have on the aircraft as well. So some of the payloads that we have available that have launched with X10 are Night Sense, which we talked a little bit about, which allows you the capability to fly at night. We have an RTK PPK module. We have a speaker mic, a spotlight, and a parachute that all are able to be configured onto the airframe very easily. And you're able to maneuver between those different attachments. Because we have these payload ports available, this also provides us the capability within the X10D variant to be able to accommodate third-party payloads as well. So we're continuously working with different vendors. We have done a lot of integration work. We're compatible with Mavlink. We're at RASA 1.2 compliant. We're doing a lot of integration work with specific people to be able to unlock capabilities and continue to grow the platform and utilize that 10x compute to be able to accomplish the mission sets that we are aiming to accomplish. And this video is showing a multi-ship integration that we've done recently, utilizing some of those common standards and the open source platform that we have available to us to be able to continue to grow. We've also made a lot of improvements on the ruggedization front, able to fly in the rain. If you look at X2 and X10 next to each other, you can see a clear difference between the X2 and X10 platform in terms of ruggedization. Really impressive hardware structure and ruggedization ability that we have there to be able to launch quickly and easily for customers and be able to be resilient against a bunch of different environmental capabilities that we have a great test suite for. And with that, I'll hand it over to Nicole to talk about the testing.
Awesome. Thanks, Kelsey. I'm Nicole. I'm the director of testing here at Skydio. So I have the fun job, but also very serious job. My team is basically the last line of defense before anything gets up to a customer. So we make sure we cross our T's and dot our I's very seriously. So today I'll kind of give everybody just a breakdown approach to our validation as a whole. We'll go into a little bit of how we do our wireless testing, our core validation, some environmental extremes that we test in, and then just some additional testing that we do overall. So my team, let's just say we start off with a new product, and Kelsey's team will decide, okay, what features are going into this product, right? And so from there, we get this feature set, and my team is responsible for kind of doing the exploratory phase. And this is the initial phase of our testing. What are these features? How are they going to work? Examples being Night Sense, blackout mode, dynamic channel switching, EO/IR tracking, right? And so we'll take all this feature set and we'll gather tons of data on how is the user going to use these skills, use these features, and we'll start developing test cases from that. And we have a large database that we capture a lot of our test cases in. It's called TestRails, which is really great because we have thousands of test cases, right? And they are across all of our product platforms and features. And so once we kind of understand the feature context, we'll start creating these test cases against these features, and we'll break those down into regression and smoke testing. And so regression for us is just every single test case, both nominal, off nominal. It may not be included in the user's nominal flow. And smoke testing is kind of like your basic from start to finish of a life cycle of the flight, right? So anything a user would generally go through in pre-flight, in-flight, post-flight, and landing media, that kind of thing. And so smoke tests are slightly different in that they're very much more important. If they fail, then it's just not a good thing. So once we develop a test cases, separate those smoke regressions, we'll run final sanities once we get this kind of final pack candidate for software. And that final pack candidate is what we're really looking at to make sure, is the user experience seamless? Do all of the features flow and operate as intended? And then in addition to when we're testing that final software or hardware, we also give ourselves really solid requirements for goals on our product, right? And so we break down, what is our total automation time that we want? What is our total manual time that we want? And we have what we call a dock warehouse, where we have these vehicles literally taking off and landing, multiple vehicles, eight to 10 all day, every day. And they're accumulating flight hours on these, both the final hardware and the final software, to understand, okay, at the end of the day, when we rack up these hours, what are our analytics? And so we have a full stream analytics dashboard where we can look at total flight time. How long is it taking a user from getting to the flight screen to actually take off? Are they hitting any faults? Have we seen any irregularities in flight? Any emergency landings? Any lost comms that shouldn't have been lost comms? That kind of thing. And so the analytics dashboards are really useful for us to understand, are we ready or not to ship the product out? And what does our performance look like? So with all of that being said, that's kind of like a brief overview of our breakdown to validation as a whole. But getting into a little bit more of the nitty gritty and pulling out some major teams that have core focus areas, one being our wireless testing team. And so this team has been really important in making sure we characterize every single environment across multiple validations. So we have the rural environments, urban environments, suburban environments, and ensuring that we run consistent band channel sweeps. And so we do this across every release, right? And we'll run band channel sweeps, making sure we don't regress. What was our performance like in the previous release versus this release? We also work really closely with the autonomy team. We're running so many tests. We're pushing these vehicles out so far. We get cool learnings like, oh, our flying at optimal speed is 13 meters per second to get our best range. Let's make sure that's working. And we're also running real world use case scenarios when we're running wireless testing, right? And so this is really based off of the customer needs, whether that be in our EAP release, but we're working with customers across all verticals to test improvements for EMI resilience of our platforms, which include, utility customers in Ukraine, just to name a few. But the wireless testing aspect is super important, and that's just kind of like one big part of the testing. Another component of our testing is our core validation. And so when I say core validation, this team specifically is involved with the controls testing, the state estimation testing, our dense mapping testing, any new features such as night sense, any changes to our vision model, encryption, that kind of thing. And so this controls team actually goes out, real world environments, validates, we call it critical validation. Making sure we didn't regress in any of our controls. If we bumped up the speed, how does that look here at sea level versus high altitude? And we're actually going to these high altitude environments and running these drones in real world use cases to make sure a customer isn't going to have any issues against the specs that we push out to everybody. And so that kind of is the core validation component. And then there's also another component to our testing, which is the just basic overall resistance to environmental extremes, right? And so cold versus hot temps. And so we run these vehicles through cold temp chambers, hot temp chambers, consistently making sure, when do we fail? Our max wind tests, what do we feel confident with the controls that we have in the vehicle performance as far as our max wind test resistance, visual navigation testing, right? And so if, like I mentioned earlier, if there is any changes to the model, running those vision-based tests against high texture environments versus low texture environments. How are we doing there? And so that's kind of the wrap up of just extreme environment testing in a release as well. And then the last two things, one is just mobile validation. So some people won't necessarily think mobile validation goes along with flight testing, but it is very important. And we have a team just dedicated to this. And they are really making sure what the customer sees from a UX UI standpoint makes sense, has flow, doesn't have any issues, right? When you're going to use blackout mode, are the toggles making sense? Does it make sense? How do you get to the toggles? Is it seamless? And so this team is really, really focused on the kind of surface level testing of our products, and it's very important, like I mentioned. And last but not least, we do a good amount of customer ride-alongs, and this is really, really useful for my team in general, just because we gather a good amount of information from the customers, and we take that back and understand how can we develop additional test cases, or what are we missing from our test cases that aren't necessarily covered in what a use case customer would use it in. And so this is kind of when we developed a lot of the different environments for scanning, different environments for tracking, EO/IR, you name it. And so the customer ride-alongs have been really, really great to hear kind of how the customers are using our product and how we can tailor our testing towards that.
RF and GPS denial, integrating those systems together to make sure that you have a layered approach to be able to overcome anything that you're encountering in the environment. As we've seen, it's incredibly dynamic. On any given day, you could be encountering any type of jamming systems, whether they're wide or narrow band, in different places at different distances. So it's really important to have all of these different layers that I outlined, all operational at once, so that no matter what you encounter, you're able to overcome that environment. So as I mentioned, kind of starting with like the basics of both of the two features, making sure that you have the frequency ranges available to be able to potentially overcome the jamming, and also the navigation solutions to be able to overcome GPS denial at a minimum. We do that by vision-based solutions, which we actually use as the primary navigation solution in a lot of cases, because it is so honed over the last 10 years to be able to be the most robust vision-based position system. And then all of those coupled together should give you a very impactful EMI solution to be able to overcome a lot of the different dynamics that you're going to encounter. But it's really important to have the next layer or two layers down of contingency management that you're able to access if you do encounter something that you hadn't encountered before, or TTPs change and tactics change and equipment change over time. You're able to fall back to those contingency measures like attitude mode, different contingency settings to save your aircraft and potentially accomplish your mission. And then also being able to go even farther from that to, okay, now there are new TTPs that nobody's ever experienced. What do we do? In a lot of cases in the past, you've needed a completely new platform, and you're basically starting over from scratch with your hardware and your sensor packages and your modularity to be able to overcome what you've seen and the new challenges that have kind of emerged on the battlefield. But that's where we've taken that next step, where no matter what you encounter, you're able to utilize the modularity and create new payloads, utilize the compute on board, tie everything together to be able to create a new TTP with an aircraft that currently exists. So not waiting that 1 to 2 to 3 years to get a new hardware platform. You're able to use the hardware platform you have, quickly iterate on the software side, and hopefully have a new TTP and a new tactic that you can employ and push to the hardware in a matter of weeks and not years.
Yeah, so let's repeat the question. So what have the newest features that have been most impactful for customers? It kind of depends on the use case. I think the X10 overall, with the improvements that we have, just in general around our sensor performance is very like the most eye-popping thing you see both in new customers and then demonstrations to customers, that the standoff ability that we discussed, the Boson Plus, just the massive improvements that we have there from a thermal capability. I think we're still early here, but the Night Sense attachment and the ability to operate 24/7 all environments is huge, especially in locations like tunnels and caves and urban canyons that we wouldn't be able to previously. Um, we touched on kind of the map capture onboard modeling. I think that's still because it's pretty new. There's not many folks doing similar things to that. It's opening up a lot of eyes on what's the art of possible, and decreasing time for workflows to get actionable intelligence from a mapping perspective. And then I think lastly, what I've seen most beyond just the general improvements with some of our functionality. Like Kelsey mentioned, our improvements in visual navigation, our improvements with RF spectrum management and things that let us operate in contested environments. Those are harder to test to and demonstrate, obviously, for various reasons. But when we've been able to, the customer's been really impressed. So, kind of the running list, I think it's all the improvements. A lot of incremental improvements and a lot of robust improvements have just made it awesome for folks to experience what X10 can do for them.
Great. Thanks, John. So I think that concludes our X10 deep dive. Thank you all so much for joining. If you have any additional questions, we're going to send out this recording and some more information, but really appreciate everyone's attendance and thank you so much.